Hi everyone, welcome to the final tutorial of the day. All of the systems, forcings, and processes we've talked about so far have contributed to past variations in Earth's climate on various timescales and will continue to influence Earth's climate in the future with the additional effect of anthropogenic forcings. So, as we've already seen in a few tutorials today, Earth's climate has varied significantly in the past. This is a record of temperature over the past 500 million years. And you can see that there have been many changes over this time. Past climate states can serve as analogs for future warming. For example, the projection temperatures for 2050 and 2100 are shown on the right, and this degree of warming is similar to past temperatures on Earth millions of years ago. So understanding the response of Earth's climate system in the past can help us to assess future changes in the climate system. It can also help to evaluate the environmental response to these changes, and it can help to validate and improve models and their projections. Later this week, you'll learn more about reconstructing past climate. And in the context of longer-term climate variations in Earth's history, the rate of recent climate change over the past 200 years is unprecedented. And we saw this already in a previous tutorial today. Current global warming is different from past warm periods in Earth's history for a few reasons. First, today, it's warming almost everywhere on Earth. It's also warming much quicker than previous warm periods. And the present-day warming is a reversal of a long-term cooling trend. And finally, it's been a long time since Earth has experienced global temperatures that are this warm. There's also a lot of evidence for current climate change in various parts of Earth's climate system. For example, surface temperatures are becoming warmer, sea level is rising, the growing season length is increasing, and ice sheets are shrinking. And all of these changes are expected to continue in the future, and Earth's climate is expected to change even further in the coming years. These four graphs are showing recent change since 1950 and projected change through 2100 in four areas of Earth's climate system. In the upper left is global surface air temperature, the upper right is global ocean heat content and sea level, the lower left is Arctic September sea ice area, and the lower right is global land precipitation. In each graph, the black line is past temperature or past climate variable simulated by models, and the teal color is the past climate variable from observations. Then the colored lines are future projections of each of these climate variables as simulated by models. And the different colored lines represent different projections of different warming scenarios, which is something that you'll learn about next week in some of the tutorials. And the shaded regions are uncertainties associated with these projections. And although there are some uncertainties associated with all of these cases, overall, these climate projections indicate a warmer temperature in the future, increased ocean heat content and rising sea level, and a decreased sea ice area. Many parts of the climate system have changed in the past in response to variations in temperature, and climate model projections indicate drastic changes to these systems in the future as well. And one climate process with global impacts that's expected to change in the future is the El Nino Southern Oscillation, or ENSO. ENSO is a climate phenomena that originates in the tropical Pacific Ocean, but has global impacts on atmospheric circulation, temperature, and precipitation. And there are two phases of ENSO that characterize variations in the system. The first is El Nino, which is a warmer than average sea surface temperature in the eastern tropical Pacific Ocean. The second phase is La Nina, which is a cooler than average sea surface temperature in the eastern tropical Pacific Ocean. And you can see some of these sea surface temperature maps of the El Nino and La Nina phases in the lower left. In this tutorial, we'll be using masking and X-ray to explore recent Pacific Ocean sea surface temperature changes related to ENSO. Specifically, we'll mask everywhere outside of the Nino 3 region, which is shown in the map on the right. The Nino 3.4 region is an area in the tropical Pacific Ocean that is commonly used as a metric for determining the phase of ENSO. By solely focusing on sea surface temperatures in this specific region, we can get a better sense of how ENSO has changed in the recent past and how it may change in the future. In later days of this course, you'll learn more about ENSO and other climate variability.